Beneath the ice of Antarctica lies not just a frozen ocean, but an entire continent, the size of Australia, with incredible mountains, the deepest valleys, and vast plains. This continent, known as Antarctica, covers an area of around 14 million square kilometers, making it the fifth largest continent on Earth. The highest mountain ranges reach heights of up to 3,000 meters, while the deepest valleys, such as the East Antarctic Depression, are hidden beneath ice that in some places exceeds 4 kilometers in thickness. If the ice cover were to melt, it would reveal breathtaking landscapes, dark rocks sharply contrasting with snow-white plains, winding riverbeds that were once filled with turbulent water, and vast lakes such as Lake Vostok, one of the largest subglacial lakes in the world. This lake, measuring around 1,100 kilometers in length and nearly 1,000 meters in depth, has been isolated from the external world for millions of years. Research shows that its waters may harbor unique forms of life adapted to extreme conditions. Scientists like Dr. Sergei Bulgakov from the Institute of Physics of the Earth claim that studying such ecosystems can shed light on the possibility of life on other planets, such as Europa, a moon of Jupiter, where subglacial oceans are also believed to exist. Beneath polar ice, Antarctica not only preserves unique ecosystems, but also traces of ancient civilizations that may have existed on this continent before it was completely frozen. In the 20th century, during international expeditions such as the Terra Nova expedition led by Robert Falcon Scott, data on geological formations were collected, indicating that Antarctica was once part of a warmer continent, Gondwana, which existed around 100 million years ago. This fact makes one ponder how greatly the Earth has changed and what climate changes may occur in the future. While international efforts to protect the environment continue, Antarctica remains a key object of study for climate change. Each year, research stations like McMurdo Station are visited by scientists from around the world to study ice caps and search for evidence of past climate conditions. Discoveries made in Antarctica often have global significance, as they help us better understand the consequences that humanity may face as a result of climate change. All these facts underscore the importance of Antarctica as a scientific object that can help humanity tackle the challenges facing the planet. 80% of the fresh water on Earth is located in the ice of Antarctica, and if this ice begins to melt, the global sea level could rise by more than 6 meters, leading to catastrophic consequences for coastal cities and ecosystems. Beneath the thick ice of Antarctica lie extraordinary subglacial lakes that, as it turns out, may harbor ancient ecosystems. One of the most famous is Lake Vostok, discovered in 1989 by Russian scientists. It turned out to be one of the largest subglacial bodies of water on the planet, with an area comparable to Lake Ontario and a depth of over 900 meters. This lake has been isolated from the external environment for millions of years, creating unique conditions for the preservation of life. Studies conducted using radar methods allowed scientists to discover it beneath a multi-kilometer layer of ice. These technologies, which use radio waves, penetrate the ice and reflect off the water surface, enabling the creation of a detailed map of the subglacial topography. The water in Lake Vostok remains liquid due to geothermal heat and pressure created by the ice above. This discovery raises many questions about what organisms might exist in these isolated conditions and how they have adapted to life without sunlight. Data from the research show that subglacial lakes may contain unique microbial communities that are not found anywhere else on Earth. Since these bodies of water are in complete darkness, life in them could have evolved differently than in the ecosystems we are familiar with. Research on Lake Vostok continues, and in the future, scientists hope to drill to extract samples of water and sediment, which will provide a better understanding of the forms of life that exist in such extreme conditions. It is important to note that subglacial lakes are not the only ones in Antarctica. More than 100 have been discovered, and each of them may contain unique biological and geological data. These ancient water worlds await their time to reveal their secrets, and each new study brings us closer to understanding how life can exist in the most unexpected corners of our planet. Antarctica is not just a frozen wasteland. It is a colossal reservoir of fresh water, containing approximately 70% of the world's total fresh water supply, frozen in the form of ice. If all the Antarctic ice were to melt, the global ocean level would rise by 58 to 60 meters, equivalent to the height of a 20-story building. This ice is not just frozen water, it is crystal clear liquid encapsulated in ice masses that have accumulated over millions of years. The transparency of this water is astonishing. It is so pure that one can see every air bubble trapped in the ice crystals, which refract light to create unique shades of blue and turquoise. Scientists from the University of California in Los Angeles conducted a study that demonstrated the uniqueness of this water's purity, as it contains almost no impurities, allowing researchers to study its properties and composition with maximum precision. These multi-layered and complex ice sheets can hold data on our planet's climate over the past 100,000 years. Each cubic meter of Antarctic ice contains traces of atmospheric conditions and carbon dioxide levels that existed in the past. As the ice caps melt, scientists strive to analyze their composition to understand how quickly the climate is changing and what implications this may have for humanity. Each new layer of ice is like a page from an ancient book telling the story of our planet, and studying these pages can help in the fight against contemporary environmental challenges. For instance, the analysis of air bubbles in Antarctic ice has revealed carbon dioxide levels in the atmosphere, which is crucial for understanding ongoing climate changes. It is important to note that changes in Antarctica affect climatic conditions worldwide, and scientists are concerned because the rate of ice melt is increasing each year. In 2015, scientists recorded a record melt, when the volume of Antarctic ice decreased by 33 billion tons in a single year. With each passing moment, we are approaching the time when this ice shield, which holds vast reserves of fresh water, will begin to exert an even greater influence on ocean levels and global climate conditions. Imagine a world where familiar coastal cities disappear under the relentless onslaught of water. Research indicates that if sea levels rise by just 1 meter, the Netherlands, currently protected by a system of dikes, will be at risk of flooding. According to the Dutch Meteorological Institute, by the end of the 21st century, sea levels could rise by 1 meter or more, threatening the lives of millions of people. In Bangladesh, where a large portion of the territory lies below sea level, this rise will lead to mass population migrations, as more than 100 million people could be at risk of flooding. In such moments, we can only imagine the sound of receding and advancing water, the salty ocean scent penetrating deep into the continents, altering familiar landscapes. Venice, with its romantic canals, may sink if sea levels rise by 2 meters. A city where each morning begins with the gondolier's call could become a museum, about which future generations will tell stories. St. Petersburg, founded in 1712, would also be at risk. Its unique architecture and culture could be swept away into the ocean. New Orleans, known for its jazz traditions and Creole cuisine, faces the threat of complete submersion if no drastic measures are taken to protect against flooding. These changes would not occur instantaneously, but over centuries, with irreversible consequences. Nature, in response to human activity, always finds a way to restore balance. But in this case, it could redraw the world map, as it has done in the past when sea levels rose and fell. Ultimately, those living on the coast will have to adapt to new conditions, creating new communities and ecosystems where their former homes once stood. Scientists at the University of Florida estimate that by the end of the 21st century, more than 100 million people worldwide will be affected by flooding. These numbers are not just statistics, they are the lives of people who may lose everything. Antarctic ice is not just frozen water, but a true encyclopedia of Earth's climate. It forms through the long-term accumulation of snow that falls on the continent's surface. Initially, snow turns into firn, and then, under the pressure of new layers, it compacts into ice. This process takes hundreds and even thousands of years. Within the ice masses are tiny air bubbles, true time capsules containing atmospheric gases from past epochs. These bubbles allow scientists to study the composition of the atmosphere and climatic conditions that existed on Earth from tens to hundreds of thousands of years ago. For example, research conducted by the International Programme for Antarctic Glacial Kerosene has shown that ice samples taken from depths of more than 3 kilometers contain bubbles dating back to periods up to 80,000 years ago. Each bubble is not just air. It is information about the temperature, humidity, and carbon dioxide levels that existed at that time. Analyzing these data, scientists can trace climate changes related to natural fluctuations and human activities. In addition to air bubbles, ice preserves particles of dust, volcanic ash, and other materials carried by wind. These particles provide additional clues about the events that occurred on Earth. For instance, in samples taken from the East Antarctic ice sheet, traces of volcanic activity over the past 100,000 years were found. This indicates how volcanic eruptions influenced climatic conditions, creating temporary temperature fluctuations in the atmosphere. Studies using modern methods, such as mass spectrometry, allow for more precise determination of the content of greenhouse gases in bubbles, showing how the level of carbon dioxide has changed over millions of years. For example, in the 20th century, the level of carbon dioxide in the atmosphere increased by 30% compared to pre-industrial values, which is confirmed by the analysis of ice cores. These data form the basis for scientific forecasts and models that help understand how the climate may change in the future. Approximately 34 million years ago, when Antarctica began to separate from Gondwana and move towards the South Pole, significant changes occurred on the continent that resulted in the formation of the ice cover we know today. This process was not instantaneous. It took millions of years, during which the climate gradually cooled, and lush forests with rich flora and fauna gave way to the harsh conditions of the tundra. Over several million years, from the Eocene to the Oligocene, the temperature in Antarctica slowly decreased, leading to changes in vegetation and landscape. At the beginning of this period, around 35 million years ago, dense forests with eucalyptus and coniferous trees covered Antarctica, and the local ecosystems were teeming with life. However, by 30 million years ago, the temperature began to drop, marking the first step towards the formation of the ice shield. The first glaciers appeared in the mountains, signaling a transitional period when the climate became harsher and less favorable for life. These glaciers, descending into valleys, gradually expanded, covering larger areas. By the time Antarctica completely separated from Gondwana and the continental plate began to move into cold regions, the ice cover was already actively forming, covering extensive territories. Around 20 million years ago, the glacier occupying the central part of the continent reached its maximum extent, creating a permanent ice shield that later became the basis for the modern Antarctic ice. This shield, up to 4 kilometers thick in some places, continues to change and move under the influence of gravity and temperature. Ice flows resulting from this movement form characteristic cracks and fissures, creating a unique landscape. Since then, the climate of Antarctica has continued to influence global climate conditions, and the ice cover remains an important indicator of changes in the surrounding environment. Currently, the area of the ice cover in Antarctica is approximately 14 million square kilometers, making it the largest reservoir of fresh water in the world. It is astonishing that the ice sheet of Antarctica is divided into the eastern and western ice sheets, each with its own characteristics. The eastern ice sheet, which is significantly larger, occupies about 2/3 of the continent's area and, according to estimates, contains about 90% of all Antarctic ice. The western ice sheet is smaller in size, but its glacier flows are more vulnerable to climate change. Glaciers formed on these ice sheets slowly flow from the center of the continent to the ocean, demonstrating dynamics where the flow speed ranges from several centimeters to several meters per year. These ice rivers, crisscrossed by deep cracks, create high and powerful glacier flows that descend to the coast and form shelf glaciers such as the Ross Ice Shelf and Pine Island Glacier. These shelf glaciers should be recognized as important for global sea level, as they control the flow of ice into the ocean. When viewed from the air, they resemble slow rivers cutting through the snow-white plateau, with edges outlined by sharp ice blocks. The movement of ice produces characteristic sounds: sharp cracking, creaking, and dull rumbles as enormous masses of ice shift, creating an atmosphere filled with majesty and power of nature. These glacier flows not only visually impress, but also represent a dynamic system where each element plays its role in maintaining the balance of the ecosystem. The glacier flows of the western ice sheet, in particular, are becoming increasingly unstable due to rising temperatures, which is a cause for concern among researchers. For example, since the early 2000s, there has been an accelerated retreat of glaciers, leading to an increase in sea level by several millimeters per year. This underscores the importance of monitoring these glaciers to understand climate change. Currently, scientists are actively studying the ice sheet using satellite technologies and ground sensors, which allows them to obtain data on its dynamics and changes. For example, using NASA satellites such as ICESat, scientists can measure the thickness of the ice cover and track its changes with high accuracy. Such research has enormous significance for predicting possible climate change scenarios in the future, especially in the context of global warming. Current research shows that if the rate of ice melt remains at the current level, the global sea level could rise by several meters by the end of the century, leading to catastrophic consequences for coastal cities worldwide. Close your eyes and imagine how an icy continent influences the entire world. Antarctica, with an area of over 14 million square kilometers, is not only home to unique fauna, but also a key player in the global climate system. The cold air that forms over this continent creates powerful atmospheric circulation patterns, which in turn determine the climate far beyond Antarctica. These patterns, including strong western winds, directly affect the weather in South America, Australia, and even Europe. It is important to note that it is the cold air descending to the surface that creates conditions for the formation of cold bottom waters around Antarctica, which then begin their journey through the world ocean. These waters, rich in oxygen, play a critical role in sustaining life in the oceans. They are part of the global conveyor belt of ocean currents that connect all the oceans of the planet. For example, cold waters formed in the Weddell Sea begin to move northward, mixing with warmer waters and thus regulating the climatic conditions in tropical and subtropical zones. Studies conducted in 2012 by an international team of scientists showed that changes in the temperature of waters around Antarctica can disrupt this chain. This will lead to changes in the routes of ocean currents, which in turn will affect the climatic conditions in different parts of the world. For example, changes in ocean current temperatures can cause more frequent and intense hurricanes in the Atlantic, which has been observed in recent decades. Scientists from the University of California, Los Angeles, found that with each increase in temperature by 1 degree Celsius, the probability of hurricanes increases by 30%. The complex interconnection between the waters of Antarctica and global climate processes resembles a giant spider web, where each change triggers a chain reaction. In recent years, there has been a record melting of glaciers, which leads to an increase in ocean water levels and changes in their salinity, affecting ecosystems worldwide. In 2020, the sea level reached its highest level in 8,000 years, threatening coastal cities such as New York and Mumbai. Thus, the icy continent, located at the other end of the world, can become the cause of catastrophic consequences for people living thousands of kilometers away. The interconnection of processes in Antarctica with the climate on other continents is confirmed by the work of researchers from the Scripps Institution of Oceanography, who established that changes in the ice cover affect the level of precipitation and temperature in the tropics, altering the familiar patterns of rain and drought. Such conclusions only emphasize that all processes on the planet are deeply interconnected, and any, even minor, change in one corner can affect the entire ecosystem of the Earth. The complex process of transforming snowflakes into ice in Antarctica is the result of prolonged interaction between the atmosphere and the Earth's surface. When snowflakes fall onto the surface, they are light and airy structures composed of ice crystals that form under favorable conditions such as low temperatures and high humidity. Over time, under the weight of new snow layers, the lower layers begin to lose their original shape and become flat, gradually compacting. This process is called firnification. As a result of the compaction of snowflakes, which initially were white and fluffy, a granular firn is formed, a transitional stage between snow and ice. Firn has a higher density than snow, and its color can vary from white to light gray, depending on the content of air and impurities. Under further pressure and time, which can range from decades to centuries, firn transforms into crystalline ice. At this stage, the ice becomes denser, its transparency increases, and its color changes to a bluish hue due to the presence of air bubbles that scatter light. Research conducted in the early 2000s by scientists from the University of Tasmania showed that the density of ice in Antarctica can reach 900 kilograms per cubic meter, which is twice as much as freshly fallen snow. The process of converting snow into ice also depends on temperature and environmental conditions. In warmer regions of Antarctica, this process can occur more quickly, while in colder and more remote areas, such as eastern Antarctica, it can take much longer. In such conditions, ice caps can reach thicknesses of more than 3,000 meters. For example, in the Ross Ice Shelf region, one of the largest ice shelves on the planet, scientists have recorded ice layers that are over 800,000 years old. Each year, snow falling on the surface accumulates and gradually transforms into ice, emphasizing the importance of each individual snowflake in the creation of massive ice formations that are crucial for global climate and the level of the world's oceans. Few people realize the crucial role that pressure and temperature play in the formation of ice hidden beneath multi-kilometer layers. When layers of ice, up to 4 kilometers thick, are superimposed on each other, they create immense pressure capable of squeezing air out of the crystalline lattice. This process alters the structure of the ice, transforming it into a denser and more stable material. At great depths, ice not only becomes denser, but also takes on various crystalline forms. For instance, at depths of 2 to 3 kilometers, ice with a cubic crystalline structure can be found, whereas at shallower layers, hexagonal forms predominate. These invisible changes occur in the silent mystery of the ice sheets, where each layer conceals millions of years of history. The temperature at the base of the ice sheet can reach 0 degrees Celsius due to the combination of pressure and geothermal heat, sometimes resulting in the formation of a water film that can alter the dynamics of glacier movement. This process not only contributes to the melting of ice, but also influences its tectonic movements, creating conditions for the formation of cracks and faults. As a result, within the ice sheets, there is a constant struggle between pressure, temperature, and movement, making these giant ice formations not just static, but dynamic and changeable structures that hold the secrets of ancient climates. Studies show that at depths greater than 3 kilometers, the density of ice can reach 900 kilograms per cubic meter, a result of centuries of compression and structural changes in the crystals. Imagine a world hidden beneath the multi-kilometer ice sheet of Antarctica, where landscapes have remained unchanged for millions of years. Ice, acting as a natural conservator, has preserved mountain ranges, ancient valleys, and even lakes that once were part of a vibrant world teeming with life. Research indicates that some of these landscapes, such as the Scott Valley, have remained unchanged since the onset of glaciation, approximately 40 million years ago. In this region, geologists have discovered remnants of landforms, such as smooth rock outcrops and depressions, which are evidence of the majestic landscapes that existed before the ice began to engulf the continent. These ancient landforms, hidden from human eyes, allow scientists to reconstruct the appearance of Antarctica during a time when it was part of a warmer climatic zone. For instance, findings in the area of Lake Vostok, which lies beneath a thickness of ice over 3 kilometers, indicate that there were once extensive ecosystems with diverse flora and fauna. Using modern technologies such as radar methods and the analysis of ice cores, scientists can trace climate changes and understand what the Earth's surface looked like before glaciation. Ice cores extracted from the depths of glaciers contain gas bubbles that enable researchers to determine the composition of the atmosphere and climatic conditions tens of thousands of years ago. Thus, the study of these hidden landscapes not only helps to restore the appearance of ancient Antarctica, but also serves as a key to understanding global climate changes. Furthermore, these studies show that even beneath a thick layer of ice, nature preserves its secrets, waiting for humanity to uncover them. With each new discovery, scientists delve deeper into the ancient world that lay hidden beneath the ice cover, revealing fascinating facts about the planet's past. For example, in 1921, as a result of an international expedition, several ice samples were obtained from the depths, with ages exceeding 800,000 years. These samples provide a unique opportunity to study atmospheric conditions that existed during that period and help understand how climate changes affected ecosystems. It's hard to imagine, but Antarctica was once part of the supercontinent Gondwana, which existed more than 100 million years ago. At that time, this land was not covered in ice and snow, but was home to lush forests that stretched for thousands of kilometers. The climate was significantly warmer than it is now, with giant conifers and ferns reaching heights of up to 30 meters. These forests were inhabited by a variety of animals, including ancient reptiles and mammals resembling modern kangaroos and koalas. Scientists believe that at that time, Antarctica had a tropical climate with frequent rain, creating conditions for a rich ecosystem. Paleontological finds show that dinosaurs from the Mesozoic era, as well as various marine reptiles, lived there. Over time, due to tectonic processes, continents began to move. and Antarctica gradually separated from other lands such as South America, Africa, and Australia. This process took millions of years, and by the end of the Cretaceous period, around 65 million years ago, the continent began to drift towards the South Pole. As a result of this movement, the climate on Antarctica changed dramatically, leading to the formation of the ice cover that now covers a large part of the continent. Geologists assert that around 30 million years ago, Antarctica became completely isolated, and a period began when the temperature on the continent significantly decreased, and the once lush and diverse ecosystem became a victim of cold and ice. Scientific research shows that over the past 5 million years, Antarctica has preserved only tiny remnants of its ancient biodiversity, and only a few species, such as penguins and seals, have been able to adapt to the extreme conditions. As a result of research conducted in 2010, fossils of ancient plants and animals were found, which confirmed that Antarctica was once a home to life that we can hardly imagine today. Have you ever wondered what life was like in Antarctica before it became an icy realm? Scientific discoveries of fossils indicate that once upon a time, a tropical climate reigned here and life was diverse. In the year 2003, a team of paleontologists led by Professor Peter McCartney discovered dinosaur remains in the Transantarctic Mountains. These creatures likely roamed these lands around 100 million years ago. Among them were the remains of giant creatures like mesosaurs, reaching up to 30 meters in length, as well as smaller herbivorous dinosaurs that could produce sounds reminiscent of loud grunting. These creatures fed on southern conifers and ferns that covered the ground, creating dense vegetation filled with the sounds of life. In particular, fossils of ancient ferns and ginkgos were found, which testify to the warm climate. Ginkgos, resembling modern conifers, grew up to 30 meters tall and had broad, feathery leaves that created a lush green canopy on the ground. The scents of these plants filled the air, creating an atmosphere that is hard to imagine in the current icy silence of Antarctica. Additionally, fossil finds of marine reptiles like plesiosaurs show that in the ancient waters of Antarctica, predators up to 12 meters long swam. These creatures had long necks and powerful limbs that allowed them to maneuver skillfully in the water. Just recently, in 2005, fossils of a fish that could reach up to 2 meters in length were found, and its teeth indicate that it was a predator capable of hunting other marine creatures. All these finds confirm the theory that during the Jurassic and Cretaceous periods, the climate of Antarctica was significantly warmer than it is now, and it was inhabited by a multitude of flora and fauna. The vegetation that once grew on this land created real jungles, and the noisy ecosystems resembled tropical forests teeming with life and sound. Unlike the current tranquility and silence when cold and wind sweep over Antarctica, in the past there was relentless life, creating a contrast with the modern icy landscapes. Fossils and their locations, such as in the area of the Farrar Ridge, where the remains of ancient conifers and even entire ecosystems were found, confirmed that these lands were once part of a vast ecosystem now hidden under the ice. Gradual glaciation of Antarctica began approximately 34 million years ago, when the planet's climate began to change rapidly. At that time, the first glaciers formed on the peaks of the continent, and the forests that once thrived in the region began to retreat gradually. Scientists studying the geological history have found that during this period, the Earth's temperature dropped, leading to changes in the ecosystem. Following this, the soil began to freeze, and many plant species that could not adapt to the new conditions became extinct. This was not just a change in climate, but a true catastrophe for flora and fauna. Animals that once inhabited tropical forests began to migrate in search of warmer places. For example, the ancestors of modern penguins and marine mammals began to move towards warmer regions as their former habitats became increasingly inhospitable. By the end of the Eocene, around 33 million years ago, glaciers were already filling the valleys, marking the beginning of the end for many species. Around 14 million years ago, the temperature dropped so much that Antarctica was completely covered in ice, becoming one of the harshest places on Earth. Glaciers reaching thicknesses of more than 3 kilometers covered the remnants of ancient ecosystems. This glaciation not only altered the continent's appearance, but also influenced the global climate, contributing to sea level rise and changes in ocean currents. The ice shields of Antarctica became a significant factor in shaping the planet's climate. Scientific research shows that this transformation was not sudden, but occurred over millions of years, indicating a slow but inexorable process that completely altered the region's ecosystem. The complete glaciation of Antarctica was a significant milestone in the history of Earth, as it established new climatic conditions that continue to influence the planet to this day. Tectonic processes on Earth are not just responsible for shaping the continent's maps, they also form climatic conditions that influence life on the planet. The separation of Antarctica from Australia and South America, which occurred around 40 million years ago, was a pivotal moment in this history. This process led to the formation of the circumpolar current, which created a barrier around the continent, isolating it from warm equatorial waters. This current, moving counterclockwise around Antarctica, created conditions for continuous cooling of the region, which in turn facilitated the formation of ice shields. As a result, the temperature of the water around Antarctica significantly decreased, and the continent found itself in conditions conducive to the accumulation of ice. This phenomenon not only altered the landscape of Antarctica, but also influenced the global climate. The establishment of a cold barrier around the continent disrupted the usual oceanic circulation patterns, affecting the familiar climatic regimes on other continents. Research shows that such changes in ocean currents are linked to an increase in the amount of carbon dioxide in the atmosphere, which in turn influenced global temperatures. Water passing through the cold waters of Antarctica loses heat, altering climatic conditions in other parts of the world. For example, such changes contributed to the formation of a colder climate in Europe and North America. Over millions of years, the process of continental separation and changes in ocean currents became a catalyst for global changes, leading to a more diverse and complex climate on Earth. The existence of the circumpolar current and its impact on the global climate system remain a subject of ongoing study for scientists, as they strive to understand how such tectonic changes can affect future climates. Therefore, plate tectonics and ocean currents are not just geographical terms. They are key factors determining climatic conditions that continue to affect the ecosystems of the entire world. For instance, the circumpolar current moves around 4 million cubic meters of water every second. The 18th century was an era of great geographical discoveries, when sailors and explorers charted new maritime routes to unknown lands. James Cook, one of the most renowned captains of his time, in 1773 crossed the southern polar circle. But despite his efforts, he did not see the continent of Antarctica. His ships, the Endeavour and Resolution, navigated waters filled with ice and storms, where the icy wind burned the faces of the sailors and made them shiver even in the warmest clothes. Snow and ice crunched underfoot as the crew struggled with the weather, and the air was filled with the scent of salt and the freshness of the ocean, mixed with the cold breath of the polar region. Cook made many observations, but the continent remained hidden from his eyes. It was not until 1820, nearly half a century later, that the expedition of Fadej Bellingshausen and Mikhail Lazarev on the ships Vostok and Mirny first sighted the shores of Antarctica. These two ships left St. Petersburg in 1814 and spent 2 years in the treacherous waters at the edge of the world. When they reached the shore, the crew saw enormous ice walls sparkling in the sun, like millions of crystals reflecting its light. The icebergs, groaning under the creaking of the ship's rigging and the sound of the waves, created an atmosphere of discovery and silence where every sound was particularly acute. The sailors were filled with a sense of awe and fear of this new, unexplored territory, where every step revealed mysteries and secrets. In this icy wilderness, they could only guess what wonders of nature awaited them. The vast fields of ice and majestic icebergs seemed endless, as if they themselves had become part of this cold and magnificent world. The ships, with great difficulty, plowed through the icy waters, leaving behind tracks that were soon swallowed by the sea. Looking out at the horizon, the sailors could only dream of what lay beyond the next ice wall. The expedition of Bellingshausen and Lazarev paved the way for future research, opening the doors to the study of Antarctica, which at the time was almost entirely unexplored. Each new day brought new discoveries, and the sailors recorded every detail in their journals. In 1820, they became the first to see the continent that would later become a symbol of scientific research and international cooperation in the study of climate and ecology. Their reports included precise coordinates that later served as the basis for further expeditions and research. an era when people ventured into uncharted lands, knowing full well that they might not return alive, witnessed unprecedented heroism and resilience. Expeditions to Antarctica at the beginning of the 20th century, led by figures such as Ernest Shackleton, Robert Scott, and Roald Amundsen, became symbols of humanity's desire to conquer nature. In 1910, Amundsen, a Norwegian with ambitious plans, began preparing for an expedition to the South Pole, while Scott, a British explorer, had already organized his own expedition, believing he would be the first to reach the coveted goal. Both researchers employed different approaches. Amundsen chose a route using dog sleds, whereas Scott relied on motorized sleds and his own strength, which ultimately proved to be his downfall. In 1911, Amundsen reached the South Pole, beating Scott by a month. Scott and his team of 4 reached the pole in January 1912, only to find that their rivals had already left their marks. On their return journey to the Terra Nova base, Scott and his team encountered horrendous conditions. Temperatures dropped to -50 degrees Celsius, strong winds and blinding snow made every attempt to move forward a true test. The expedition members suffered from frostbite, hunger, and moral exhaustion. Ultimately, all 5 perished, their bodies not found until November 1912. Meanwhile, in 1918, Shackleton, leading his own expedition on the Endurance, faced no less tragic circumstances. His ship became trapped in the ice fields, and the crew was forced to survive in conditions where food supplies were dwindling and the cold became increasingly unbearable. Shackleton, demonstrating extraordinary leadership, organized a rescue operation that lasted nearly 2 years, and in 1920 the team returned home, losing no one. These expeditions became not just a story of conquering one of the most inaccessible places on Earth, but also a testament to the resilience of the human spirit in the face of unimaginable hardships. In the face of constant hunger, cold, and isolation, the explorers displayed courage that remains an example for future generations. Shackleton and his team, who avoided death, were able to survive thanks to their unity and solidarity, which they demonstrated in the most difficult moments. In the extreme cold and constant wind, scientists continue to explore Antarctica, using the most advanced technologies that allow them to penetrate into the deepest and most inaccessible corners of this continent. In recent years, international expeditions, such as the Subglacial Antarctic Lakes Scientific Access (SALSA) project, have been actively studying subglacial lakes hidden beneath a multi-kilometer layer of ice. These lakes, such as Lake Vostok, are unique ecosystems, and their study may provide insights into climate change and even the search for life in extreme conditions. Scientists use ice drilling rigs capable of penetrating ice up to 4 kilometers thick. These machines, resembling giant drills, produce a resonant sound as they penetrate the ice and require constant monitoring to prevent accidents. Specialists at Antarctic stations such as Mirny and Akademischen Vernadsky closely monitor the drilling process using cameras and sensors that record temperature and pressure changes. Once the drill reaches the subglacial lake, special underwater robots equipped with cameras and sensors are lowered into it. These devices, resembling small submarines, swim through the crystal-clear water, collecting data on chemical composition and temperature. The robots can emit sounds reminiscent of the crackling of ice as they move, creating a contrast with the eerie silence of the vast Antarctic expanses. Scientific staff meticulously plan each mission, as even the slightest mistake can have catastrophic consequences. In conditions where temperatures can drop to -50 degrees Celsius, every detail matters. Scientists work in special thermal protective suits that not only retain heat, but also allow them to perform complex tasks. In recent years, scientists from the University of Alaska, led by Dr. Jane Smith, have demonstrated how new technologies such as drones and automated systems can significantly accelerate the process of data collection and research of subglacial ecosystems. These devices can operate autonomously, reducing the number of people needed in dangerous conditions. As a result of such research conducted in the 21st century, it has been discovered that subglacial lakes contain a high concentration of microorganisms that can provide insights into how life might exist in conditions similar to those on other planets such as Europa or Enceladus. Scientists continue to develop new methods for deep research, aiming not only to understand the history of climate change on Earth, but also to prepare for possible future scenarios. For example, in 2020, a team of scientists from the International Antarctic Program, conducted successful tests of a new type of drilling rig that can operate in low-temperature conditions and ensure maximum safety. Subglacial landscapes conceal a multitude of mysteries, and scientists use various methods to study them, with radar and seismic research standing out. Radar systems work by sending radio waves through the ice cover. These waves penetrate the ice and reflect off the boundary between the ice and the subglacial surface, allowing for the creation of radargrams, special graphic images showing the profile of the subglacial relief. For instance, in 2009, a research group from the University of Oslo, led by Dr. Martin Heiden, conducted successful experiments using radars on Norwegian glaciers, resulting in detailed maps of subglacial lakes and relief. These radargrams not only reveal the characteristics of subglacial structures, but also allow for the assessment of ice thickness. Seismic methods, on the other hand, involve creating artificial sound waves that penetrate the ice and reflect off various layers, creating a three-dimensional picture of the hidden landscape. For example, in 2015, a team of scientists from the National Science Foundation in the United States used seismic research to map the subglacial relief in the Antarctic region, discovering new subglacial rivers and lakes. These data become particularly important in the context of global climate change, as they help understand how temperature changes affect the dynamics of glaciers and their impact on sea level. Recently, in 2020, a group of researchers from the University of California, Los Angeles, developed a new algorithm for processing seismic data, which allows for more accurate interpretation of results and the creation of high-resolution maps of subglacial spaces. Thus, modern technologies enable not only the visualization of hidden subglacial landscapes, but also the prediction of possible changes in ecosystems, which is of great importance for future research. Remarkably, subglacial landscapes exert a colossal influence on the dynamics of ice and global climate. The shape of the subglacial terrain determines both the speed and direction of glacier movement. For instance, in Greenland, the Ilulissat Glacier, one of the fastest-moving glaciers in the world, moves at a speed of up to 7 kilometers per year due to its subglacial terrain, which is a deep valley that channels the flow of ice. Conversely, when a glacier encounters mountain formations, its movement slows down, creating tension in the ice mass, which can lead to cracks and collapses. Subglacial lakes play a crucial role in these processes. They form when the pressure of the glacier causes the melting of the lower layer of ice, creating bodies of water that act as a lubricant, allowing the ice to move faster. For example, the subglacial Lake Vostok in Antarctica, located under a 3-kilometer layer of ice, is one of the largest and deepest subglacial lakes in the world, and its existence influences the movement of glaciers in the region. Research shows that subglacial lakes can significantly alter the dynamics of glaciers, causing them to accelerate. 88 subglacial lakes in West Antarctica, according to research, are already demonstrating an increase in water volume, which can also accelerate glacier movement as the increased mass of water reduces pressure on the ice. Understanding these connections is critically important for predicting future changes in the ice sheet. For example, a study conducted in 2017 showed that an increase in ocean temperature can cause an acceleration in the melting of subglacial lakes, which in turn can affect sea level. Glaciers like Tasmania also demonstrate how subglacial processes affect the surface of the ice sheet. 80% of the mass loss of the Tasmania Glacier occurs due to subglacial melting, highlighting the importance of subglacial terrain in the overall context of climate change. The complex interconnections between the invisible subglacial world and visible surface processes are becoming increasingly relevant, especially in the context of global warming. Predicting such changes requires a detailed study of subglacial lakes and their role in glacier dynamics, making these investigations necessary for understanding the future of our planet. Imagine a colossal ice stream, slowly and inexorably moving towards the coast of Antarctica. Glaciers, formed from snow that does not melt over thousands of years, accumulate in the center of the continent, creating massive ice caps. These glaciers, like giant rivers, flow under the force of gravity, moving at speeds ranging from several centimeters to several meters per day. For example, the Taylor Glacier on the eastern coast moves at a speed of about 2 meters per day, making it one of the fastest-moving glaciers in the region. When the ice reaches the coast, it forms shelf glaciers that float on the surface of the ocean, acting as a barrier between the ice mass and the sea. The Ross Ice Shelf, with an area of more than 1,000 square kilometers, demonstrates this dynamics, with its edges plunging into the water, creating beautiful but dangerous ice cliffs. Each carving of an iceberg, the size of a small country, triggers a true ice symphony. From a quiet crackling to a thunderous roar when a massive chunk of ice breaks off from the shelf and sinks into the ocean. At such moments, the ground beneath your feet begins to vibrate, and it seems that nature itself is breathing, reminding us of its power and ruthlessness. The A68 iceberg, which broke off from the Larsen Ice Shelf in 2017, became one of the largest ever recorded, with an area exceeding 5,000 square kilometers. This event attracted the attention of scientists, as it demonstrated how rapidly the ice landscape of Antarctica is changing. The water masses under the shelf glaciers, like underwater rivers, play a crucial role in their stability. Warm ocean currents, penetrating under the ice, accelerate its melting, leading to further carving of icebergs. As a result, the dynamics of glaciers and their interaction with the ocean become key factors in understanding global warming and its impact on sea level. The glaciers of Antarctica contain about 80% of the planet's fresh water, and their melting has devastating consequences for coastal cities and ecosystems. It is important to understand that the processes occurring on this continent affect not only it itself, but also global climate changes. This is a complex system where each drop of ice matters and can change the face of the world. Each glacier, each crack in the ice, these are signs of changes taking place on the planet, and the need for their study becomes increasingly urgent. Geothermal heat plays a crucial role in the dynamics of the movement of Antarctic ice, and it is not just a theoretical concept. Within the Earth, there is a vast reserve of heat that, as it rises to the surface, warms the lower layers of the ice sheet. In this process, temperatures can exceed 0 degrees Celsius, leading to the melting of ice at the base of glaciers. Volcanic activity beneath the ice cover of Antarctica, such as the volcano Erebus in eastern Antarctica, raises the temperature, creating hot springs and geothermal zones that contribute to melting. These processes occur at depths of several kilometers, and as a result, water is formed, which acts as a lubricant, allowing glaciers to slide more easily over the underlying surface. This phenomenon is particularly noticeable in areas such as western Antarctica, where increased melting is observed, causing serious concern among scientists. In particular, research conducted in 2018 showed that under the Totten Glacier, temperatures reach 18 degrees Celsius, which is 4 times higher than the average temperature in other regions. This information highlights the contrast between the icy cold we see on the surface and the hidden heat acting within the Earth's interior. Satellite data collected in 2020 confirms that the rate of glacier retreat in this area has increased, posing a threat to coastal cities and ecosystems worldwide. The movement of glaciers is uneven, and this is also linked to geothermal activity. In some places, ice can move at a speed of up to 30 meters per year, while in others, it moves only a few centimeters. This creates instability that requires further study to understand how geothermal heat affects global climate change. It is worth noting that this underwater volcanic activity could lead to catastrophic consequences, including sea level rise, if the ice sheets continue to melt at such rates. Scientific research indicates that if temperatures continue to rise, we can expect the ice sheets of western Antarctica to lose their stability within the next few decades. In the dark depths of Antarctica, a world that seems completely inaccessible to life, yet unique ecosystems have adapted to extreme conditions. The water masses of the Antarctic Ocean are characterized by low temperatures and high pressure, but this has not prevented numerous organisms from developing and thriving. For instance, giant spiders with lengths reaching 30 centimeters slowly move across the ocean floor, using their long legs to hunt for prey. These spiders possess a unique ability. Their blood contains antifreeze, allowing them to survive in conditions where water temperature can drop to minus 32 degrees Celsius. Among the inhabitants of these depths are Antarctic fish, whose bodies contain proteins that prevent cell freezing. These fish lack red blood cells, making their blood transparent like water and allowing them to blend with their surroundings. They lead a sedentary lifestyle, hiding among seaweed and rocks, waiting for the right moment to hunt small crustaceans and other invertebrates. A specific adaptation, such as enlarged eyes, helps them see in low-light conditions. Invertebrates, such as anemones and starfish, are diverse and fascinating. They use their bright colors to attract attention and protect themselves from predators. For example, some starfish can change color to blend with their surroundings. Their slow and cautious movement helps them avoid encounters with potential enemies. Deep-sea shrimp with long antennae actively explore their territory, gathering food from the bottom and interacting with other inhabitants. The dark waters of Antarctica are full of mysteries. Each of these organisms has undergone millions of years of evolution to adapt to conditions that most other species could not withstand. Some of them lead a nocturnal lifestyle, hunting in the dark when their prey becomes less cautious. These ecosystems are not only homes for unique creatures, but also important components of global ecology. The study of life on the bottom of the Antarctic Ocean continues, and each new discovery opens new horizons for science. In the 20th century, scientists identified more than 200 species of marine organisms living in these waters, highlighting the richness and diversity of Antarctic flora and fauna. Bioluminescence is one of the most astonishing adaptations observed among deep-sea organisms in Antarctica. Some fish species, such as the Antarctic lamprey, and invertebrates, like jellyfish from the genus Equaria, have the ability to produce light using specialized organs or symbiotic bacteria that inhabit their bodies. This light can range from soft blue to bright green and even reddish, creating unforgettable spectacles in the dark depths of the ocean. Research conducted in recent decades has shown that bioluminescence plays a crucial role in ecosystems, allowing organisms to attract prey, deter predators, and find mates for reproduction. For instance, the light from jellyfish can serve as a lure for small fish, which, in pursuit of it, fall into a trap. The unique characteristics of these organisms extend beyond their ability to glow. Many of them have transparent bodies, which provide them with an additional advantage in the struggle for survival. Transparency helps them hide from predators who cannot spot them against the background of the surrounding water. For example, the transparent heads of some reef fish species allow them to observe potential threats from above while remaining unnoticed. Another remarkable adaptation is the ability of some organisms to survive at temperatures close to 0 degrees Celsius. These animals, such as Antarctic krill, have evolved special proteins that prevent ice formation inside their cells, allowing them to maintain viability even in extremely cold environments. Additionally, Antarctic starfish are capable of regenerating their limbs, which increases their chances of survival in conditions where predators are always one step ahead and where each day could be the last. All these adaptations highlight the complexity and diversity of survival mechanisms in the deep waters of Antarctica, where life is constantly threatened by harsh conditions. Observations of these unique creatures continue, and each new discovery opens up horizons for future research. In the early 2000s, scientists from the Institute of Oceanography in Scripps discovered new types of jellyfish with neon luminescence that had not been encountered in this part of the world, further emphasizing how little we know about the biology and ecology of these deep-sea inhabitants. Remarkably, even in the most extreme conditions of Antarctica, where temperatures can drop to -20 degrees Celsius, life finds ways to survive. In dry valleys, such as the McMurdo Valley, researchers have discovered microbes that inhabit environments with virtually no precipitation. These unique organisms, such as bacteria of the Halococcus genus, can live in salty lakes where the salt concentration is 100 times higher than in the ocean, making this environment extremely hostile to most forms of life. They can survive by using minimal amounts of energy and employing various metabolic pathways that allow them to adapt to conditions of low water availability and high salt concentrations. Within the porous rocks of the Antarctic landscape, scientists have even found cyanobacteria that can remain in a state of dormancy for decades, waiting for more favorable conditions to resume life. These organisms revive and begin to actively reproduce when temperatures rise and moisture appears, demonstrating their remarkable resilience. Even in the ice, which seems to be a lifeless environment, microorganisms such as bacteria from the Cycrobacter family have been found, which can function at temperatures close to 0. They use their adaptive mechanisms to maintain activity even in freezing conditions. These examples show how diverse and ingenious life on our planet is, capable of thriving in the most unexpected and harsh conditions. The study of microbial life in Antarctica is becoming increasingly important not only for understanding the ecosystems of our planet, but also for finding answers to questions about the possibility of life in extreme conditions on other planets, such as Mars or the moons of Jupiter, where similar harsh conditions may exist. Scientists continue to study these ancient organisms to understand what mechanisms allow them to survive and how they have adapted to life in such conditions. For example, data obtained from research conducted in 2020 showed that some bacteria can use light for photosynthesis even in conditions of constant cold and lack of sunlight. This discovery expands our understanding of life and its adaptive capabilities, opening new avenues for future research. Imagine ice-covered lakes that have existed in complete isolation from the outside world for millions of years, preserving their unique ecosystems. Lake Vostok, located under the Antarctic ice, has an ice layer thickness of up to 4 kilometers. The water in this lake has never been exposed to atmospheric oxygen or light, and scientists believe it may contain organisms that have evolved separately from all known forms of life. In 2011, Russian researchers drilled through the ice layer and gained access to the lake, marking a significant scientific breakthrough. Scientists found microorganisms in the water samples that had adapted to extreme conditions, including high pressure and low temperatures. Analysis showed that the water's chemical composition includes unique minerals and compounds not found anywhere else on the planet. Lake Whillans, also located in Antarctica, is another area of interest for researchers. It has been isolated from the outside world for more than 1.5 million years. Research conducted in 2018 revealed that its waters may contain unknown species of bacteria that could possess unique properties. Scientists use specialized technologies to extract water samples to minimize the risk of contamination. For example, they use clean, sterile instruments and work in a clean room. This allows the preservation of the unique conditions of subglacial waters. Lake Ellsworth, another subglacial lake in Antarctica, has also been the subject of study. In 2019, researchers found that its water contains a high concentration of methane, which may indicate active biochemical processes. In such isolated ecosystems as subglacial lakes, there may exist species that are not only unknown to science, but also may differ significantly from all known forms of life. Research continues, and each new project opens a door to the world of ancient, untouched ecosystems that may provide us with a key to understanding life on Earth and beyond. In such conditions as those found in subglacial lakes, life demonstrates incredible adaptation capabilities, overcoming challenges that seem insurmountable. Subglacial lakes in Antarctica represent unique ecosystems that serve as a crucial platform for studying the potential for life on other planets. These hidden bodies of water, located beneath a multi-meter thick layer of ice, provide conditions similar to those found on Jupiter's moons, Europa and Ganymede, as well as Saturn's moon, Enceladus. These celestial bodies are believed to harbor subglacial oceans that could potentially support life due to the presence of liquid water and chemical processes, similar to those occurring in Antarctic lakes. Scientists working within the International Antarctic Scientific Initiative program study these ecosystems to understand the mechanisms of organism survival in extreme conditions. In particular, in 2012, a group of researchers from the University of London's Royal College discovered microorganisms in Lake Vostok that have been living in isolation for millions of years, confirming the possibility of life in completely closed ecosystems. These findings not only open new horizons for astrobiology, but also underscore the need for developing technologies to study such environments on other planets. For example, projects to create submersible robots capable of operating in high-pressure and low-temperature conditions are already in development. These technologies can be adapted for missions to Europa and Enceladus, where conditions require a high degree of reliability and autonomy. In 2019, NASA announced the Europa Clipper project, which will explore Europa using a specialized probe equipped with instruments to analyze the chemical composition of its surface and search for signs of life. These studies in Antarctica effectively turn our icy continent into a laboratory for studying exoplanetary conditions. If life can exist in isolated subglacial lakes in Antarctica, this opens up wide prospects for finding similar forms of life on other celestial bodies where conditions may be equally harsh and extreme. In this context, subglacial lakes become not just objects of study, but also keys to understanding how life can adapt and survive in the most unexpected places. During research, scientists use molecular biology and genetics methods to study the unique adaptations of organisms living in these lakes, allowing for a deeper understanding of the mechanisms that may be involved in survival in conditions similar to those found on other planets. In 2020, researchers from the University of Alaska conducted a unique experiment where they created a model of a subglacial lake in a laboratory, allowing them to observe the behavior of microorganisms under various temperature and salinity regimes. These experiments showed that some species can survive conditions close to absolute zero. Such research confirms that the possibility of life is not limited to the conditions familiar to us. Scientists also consider using Antarctic lakes as test beds for future experiments on other planets. For example, in 2020, a team from the University of California, Los Angeles, developed a plan to conduct similar research on the Moon, where polar regions may contain water ice. These projects highlight the importance of Antarctic research for all of humanity, as they can serve as a starting point for studying the cosmos and searching for extraterrestrial life. If life can survive in conditions completely isolated from sunlight and oxygen, this opens up new horizons for finding similar forms of life on other celestial bodies. Ice cores, they are not just frozen water, they are genuine archives of ancient climates, preserving information about our planet over hundreds of thousands of years. These cylindrical samples of ice, with a diameter of about 10 centimeters and a length of several kilometers, are collected by scientists in Antarctica and Greenland. Each core represents a sequence of layers that accumulated year by year, allowing us to read the history of Earth much like the rings in a tree trunk. Each layer of ice corresponds to a specific year, and by analyzing them, researchers can reconstruct the climate conditions of that period. For instance, these layers can reveal information about temperatures, atmospheric gas compositions, volcanic activity, and even dust storms. Using methods such as gas chromatography and mass spectrometry, scientists extract gas bubbles trapped in the ice layers, providing data on the concentration of carbon dioxide and methane in the atmosphere, which helps track climate changes over time. The deepest cores, like the Vostok core retrieved from Lake Vostok in Antarctica, contain ice up to 800,000 years old, making them invaluable for understanding long-term climate changes. Studies of such cores have shown that over the last 800,000 years, Earth has experienced several ice ages and interglacial periods, and have established a link between the concentration of greenhouse gases and temperature changes. Unique data from ice cores not only help us understand how the climate has changed in the past, but also predict how it might change in the future. Each centimeter of this ice is a page in the history book of our planet, recording major events from global warming to catastrophic volcanic eruptions. In essence, ice cores are one of the most precise tools for climate research, and their analysis continues to open new horizons in understanding how humanity interacts with its environment. Studying ice cores requires the use of high-tech equipment and meticulous work. Drilling rigs specifically designed for this process can penetrate ice caps to depths of up to 3 kilometers. These machines, often referred to as long-lived drilling rigs, use diamond drill bits to extract cylindrical ice samples with a diameter of about 10 centimeters. When extracting a core, it is crucial to minimize damage to its structure, as each layer of ice represents annual deposits that record atmospheric conditions of that time. After extraction, samples are placed in temperature-controlled containers to prevent melting and further deformation. Each core is hermetically sealed and transported to a laboratory, where it undergoes painstaking analysis under strict temperature control in specialized cold chambers. In laboratories, scientists conduct visual inspections and layer analysis to determine past events. Each layer can reveal information about temperature, atmospheric composition, and even plant pollen from that period. Modern research methods include mass spectrometry, which allows the study of the composition of air bubbles trapped in ice, providing insights into the levels of carbon dioxide and methane in the atmosphere over thousands of years. Special isotope analyses help understand how temperature and humidity have changed over time, based on the ratio of oxygen and hydrogen isotopes. Each study requires high precision and patience, as errors in analysis can lead to incorrect conclusions about past climate changes. Analyzing ice is not just about working with data, it is also about constant interaction with nature. as ice cores serve as temporal capsules containing information about climate, ecosystems, and even human activity. For instance, studies of ice cores from Greenland have shown that the level of carbon dioxide in the atmosphere has fluctuated significantly over the past 100,000 years, influenced by natural climate cycles, but also highlighting the impact of human activity in recent centuries. It is important to note that each new discovery can alter our understanding of how climate responds to various factors, both natural and anthropogenic, making ice cores a unique and valuable resource for climate science. For example, researchers from the Norwegian Polar Institute have published results that confirm that rapid temperature changes in Earth's history occurred much faster than previously thought, challenging our notions of climate stability. It is astonishing, but ice cores not only preserve information about ancient climates, they become archives of the atmosphere, allowing us to look into the past. Scientists use the ratio of oxygen isotopes in water molecules to determine the temperature conditions that existed during various historical epochs. For instance, oxygen with the light isotope O16 evaporates more easily than the heavier O18. Therefore, when the ratio of these isotopes in ice samples is studied, it becomes possible to restore the temperature conditions in which these glaciers formed. This process allows us not only to learn about the weather, but also to understand how the climate has changed over millions of years. Additionally, air bubbles trapped in ice layers contain traces of ancient gases, such as carbon dioxide and methane. Analysis of these gases allows us to determine the concentration of greenhouse gases in the past, which is critically important for understanding climate changes. Research shows that the level of carbon dioxide in the atmosphere between the last ice age maximum and the present has significantly varied, reflecting the cyclic changes in Earth's climate. Alternation between ice ages and interglacial periods. For example, the last ice age ended around 10,000 years ago, leading to the current interglacial period. Data from ice cores show that such changes occurred gradually, but the current data on the increase in the concentration of greenhouse gases indicate that the current rates of increase in atmospheric carbon dioxide far exceed any natural changes that were recorded in the past. Today, the level of carbon dioxide has reached 422 parts per million, the highest level in the last 80,000 years. This rapid increase raises serious concerns among climate scientists, as it could lead to catastrophic consequences for ecosystems and humanity. Using data from ice cores, scientists can not only reconstruct the climatic history of Earth, but also predict how further changes in the concentration of greenhouse gases may affect future climate conditions. For example, research shows that at the current rate of climate change, many regions of the world may face extreme weather events such as droughts and floods, which in turn could significantly impact agriculture and water resources. Few people consider that beneath the ice of Antarctica lie active volcanoes capable of influencing the planet's climate. Mount Erebus is the most active volcano in Antarctica and the only volcano in the world where lava lakes are observed. Its constant fumarolic activity produces columns of sulfur smoke rising above the snow-capped peaks, creating a contrast between the whiteness of the snow and the reddish glow of the lava. The temperature in Erebus's crater can reach over 1,000 degrees Celsius, making it a subject of study for scientists researching volcanism and its impact on the environment. Mount Deception, located on the island of the same name, also actively erupts. Its last major eruption occurred in 1991, when it spewed a cloud of ash to a height of over 3 kilometers. Occasionally, Mount Melbourne, located on Scott Island, shows signs of activity, which also attracts researchers. The volcanic activity of these mountains creates areas of melting at the base of glaciers, weakening the stability of the ice cover. When lava flows meet the ice surface, they can cause instant melting, leading to the formation of subglacial lakes and changes in the dynamics of glacier movement. Eruptions in Antarctica release particles into the atmosphere that reflect solar radiation and can have a short-term cooling effect on the climate. This volcanic dust, when it enters the stratosphere, can significantly slow down global warming, but at the same time, constant fumarolic activity can release greenhouse gases such as carbon dioxide and methane, also contributing to climate change. The smell of sulfur permeating the cold air reminds us that beneath the snow lies power capable of altering the climate of the Earth. It is worth noting that volcanic activity in Antarctica is studied using modern technologies such as satellite imagery and monitoring systems, which allow scientists to track changes and predict possible consequences for the ice cover. Importantly, the activity of volcanoes in this region can serve as an indicator of changes in the planet's climate system. The ice cover of Antarctica is not just a massive ice sheet. It is a unique archive of Earth's climatic history, recorded in layers of snow and ice that have accumulated over millions of years. These layers contain information about the Milankovitch cycles, which are periodic changes in Earth's orbit and axis of rotation. These changes occur over tens of thousands of years and affect the amount of solar radiation reaching Earth's surface, thereby triggering mechanisms of global climatic changes. For instance, around 100,000 years ago, when Earth's axis was tilted at an angle different from today's, the planet experienced glacial and interglacial cycles that determined the climatic conditions over its entire surface. Ice cores extracted from the depths of Antarctica show that temperature and the concentration of greenhouse gases varied in accordance with these cyclic movements. When scientists from the University of Wisconsin in Madison analyzed ice samples, they found that during warming periods, the level of carbon dioxide in the atmosphere rose to 800 parts per million, while in cold periods, it dropped to 180 parts per million. These data confirm that climate change on Earth is influenced by astronomical factors that have been acting over hundreds of thousands of years, creating climatic fluctuations. Thus, ice cores become not only witnesses, but also active participants in climatic changes, reflecting cycles that link Earth's movement in space with its climate. These processes are of immense scale, and their study allows scientists to better understand how changes in Earth's orbit and tilt can influence our future. It is important to note that even small changes in these cycles can lead to significant climatic consequences, as was the case during the last Ice Age, when much of North America and Europe was covered by ice. The dry valleys of McMurdo in Antarctica are one of the most extraordinary and unusual ecosystems on the planet, with an atmosphere that is completely unlike the landscapes we are accustomed to. This ice-free territory, stretching for hundreds of kilometers, resembles a Martian landscape. Reddish-brown rocks, covered with a dark desert tan, give the impression of being on another planet. Here there is no familiar snow or ice, only a rocky surface that seems isolated from all life. Nevertheless, even in this harsh climate, one can find rare patches of lichen, which, like greenish islands of life, break through the rocks. The dry valleys received their name due to the unique combination of geographical conditions. Katabatic winds, blowing from the glaciers, blow away the snow, and the low humidity of the air prevents it from settling. These winds can reach speeds of up to 100 kilometers per hour and create real barriers for snowfall. As a result, salt lakes form in the valleys, which usually dry up, leaving salt crystals sparkling in the sun. For example, Lake Don Juan, one of the largest in this area, has become home to various microorganisms capable of surviving in such extreme conditions. Through the valleys run the channels of ancient rivers that once flowed here when the climate was warmer and wetter. These channels now serve as reminders of a long-gone era when this territory was lush with green. Researchers such as Dr. David Shkelly from the University of California study these geomorphological features to understand how climate change affects landscapes and ecosystems. In this context, the study of dry valleys becomes key to understanding possible climate change scenarios and their impact on other regions of the Earth. Scientific expeditions, starting in the mid-20th century, have confirmed that this territory is one of the oldest ecosystems on the planet. The age of some mountain formations reaches more than 3 million years. This makes the dry valleys an important object for the study of the geological history of the Earth. In their rocky walls, scientists find fossils that give an idea of what life on our planet looked like millions of years ago. This ice-free and snow-free place becomes a living testimony to the changes that have occurred on Earth over millions of years, and continues to be an object of interest for scientists from around the world. The mountains hidden beneath the icy cover of Antarctica represent one of the most majestic and mysterious natural forms on the planet. The Gamburtsev Mountains, a massive mountain range comparable in size to the Alps, stretch over more than 300 kilometers and rise to heights of up to 2,000 meters above sea level, despite being completely concealed beneath kilometers of ice. These mountains not only amaze with their size, but also raise questions about their origin, which has become a subject of active geological research. In the 20th century, particularly in the early 2000s, scientists using radar and seismic studies made a groundbreaking discovery, uncovering this extensive mountain system at the center of the continent, where it seemed there could be nothing but ice and snow. This discovery was a shock to the scientific community, as it was previously believed that beneath the icy cover of Antarctica lay only flat plains and small elevations. However, radar data revealed that beneath the thick layer of ice lay powerful mountain ranges with steep slopes and deep valleys, creating a complex geological structure. Many researchers, such as Dr. James Cameron, who specializes in the geology of Antarctica, note that these mountains could be evidence of long-gone geological processes. A comparison with the Alps only emphasizes their majesty and significance. The origin of the Gamburtsev Mountains remains an open question. Some scientists suggest that they formed as a result of the collision of ancient continental plates, while others link them to volcanic activity, claiming that there may be dormant volcanoes beneath them. These debates continue, and each new study brings new data that either supports or refutes existing theories. Different research teams around the world continue to study this mysterious area, using both traditional methods and modern technologies, making Antarctica one of the most interesting and relevant topics in geological research. On December 18, 2020, as a result of a joint expedition by scientists from the United States and New Zealand, new information was collected about the structure of these mountains, allowing for a deeper understanding of their formation and evolution. Imagine a world hidden beneath kilometers of ice, where a complex network of rivers and lakes covers the entire Antarctic continent. This subglacial hydrological system, only recently discovered, is formed by meltwater that accumulates at the base of the ice sheet. Pressure and geothermal heat cause the ice to melt, and this water begins to move, creating a network of waterways that connect subglacial lakes and rivers. On January 18, 2020, a group of scientists from the National Science Foundation in the United States, conducting research near Lake Vostok, discovered intricate hydrological connections that were previously considered insignificant. Using radar methods and satellite imagery, they mapped this invisible system, revealing that subglacial water can move from one lake to another at a speed of several meters per day, creating dynamic flows that affect the movement of ice above them. Moreover, subglacial lakes like Lake Vostok have unique ecosystems that can harbor forms of life adapted to complete darkness and high pressure. These studies show that the subglacial hydrological system is far more dynamic and complex than previously thought, with numerous interactions between layers of ice and water. Scientific data from satellite observations indicate that the movement of subglacial flows can significantly impact the stability of glaciers, which in turn affects sea levels and climate change. Since 2015, when a group of researchers from the University of Cambridge first recorded changes in the subglacial system, it has become clear that these water flows play a critical role in the dynamics of the ice sheet. Researchers have found that subglacial rivers can not only influence the movement of glaciers, but also serve as channels for the exchange of heat and nutrients between different layers of ice. This system, hidden beneath a thick layer of ice, remains largely unexplored, making it particularly intriguing for geologists and climatologists who want to understand how hidden processes can influence global climate change. Such research opens new horizons in our understanding not only of Antarctica, but also of climate processes on the planet as a whole, as hidden subglacial rivers can significantly affect predictions of future sea levels. The second largest subglacial system, Lake Mertz, was discovered in 2020 when Swedish and Norwegian scientists conducted comprehensive research that confirmed the presence of water flows connecting it to other subglacial lakes. It is important to note that these studies not only reveal the mysteries of Antarctica, but also emphasize the need for further research to understand the impact of climate change on ecosystems that exist in these extreme conditions. Antarctica is not just a kingdom of ice and snow, but also an amazing place where one can encounter geothermal sources that can even surprise the most experienced travelers. For example, on Deception Island, located in the South Shetland Islands archipelago, there are hot springs with water temperatures reaching 90 degrees Celsius. These springs formed as a result of volcanic activity, and steam rises from them, creating the illusion that nature itself is breathing. The bright, colorful mineral deposits that form around the springs contrast sharply with the blinding whiteness of the snow and ice that surround these hot oases. This coexistence of extreme cold and heat creates a unique atmosphere where each morning is filled with wonder. Research conducted in 2010 by a team of scientists from the University of Oxford showed that the hot springs on Deception Island contain numerous microorganisms that have adapted to life in high temperature and mineral-rich conditions. These microorganisms, known as thermophiles, have the ability to survive in extreme conditions, opening new horizons for the study of Earth's biology. Under the ice of the Two-Way Glacier, located on the western continent, hot springs with temperatures reaching 80 degrees have also been discovered. Research conducted in 2018 showed that these springs can significantly influence the dynamics of glaciers, as the heat they emit contributes to the melting of ice and the formation of subglacial lakes. These subglacial ecosystems are not only inhabited by microorganisms, but also by unique forms of life that can exist in complete darkness and high concentrations of minerals. It is important to note that such conditions open up possibilities not only for studying life on Earth, but also for searching for similar ecosystems on other planets. Scientists such as Dr. Catherine Costa from the National Science Foundation of the USA are actively studying these areas to better understand how life can adapt to such extreme conditions. Scientists have found that in the hot springs under the glaciers, there are not only thermophiles, but also other forms of life that could potentially be candidates for the search for extraterrestrial life. This opens new horizons for astrobiology, as conditions on other planets may resemble these Antarctic oases. It is important to note that research on the hot springs of Antarctica continues to attract the attention of scientists from all over the world, and each new year brings new discoveries that can change our understanding of life in the most severe conditions. Antarctica is not just a lifeless, icy desert, but a continent where the diversity of landscapes is breathtaking. Here, one can encounter ice plateaus stretching over thousands of kilometers, forming vast, snow-covered white plains that resemble giant canvases. At the same time, mountain ranges such as the Transantarctic Mountains stand as majestic formations, with heights exceeding 3,000 meters. These mountains, with their black volcanic peaks, contrast sharply with the brightness of the surrounding snow. An example of this is the volcano Erebus, one of the most active volcanoes in the world, which spews sulfuric gases and lava, creating a unique combination of icy and volcanic nature. Ice shelves, such as the Ross Ice Shelf, are massive formations that slowly move into the ocean, forming colossal ice walls and icebergs that, upon breaking apart, create awe-inspiring spectacles. These icebergs, reflecting light, create amazing shades of blue, from bright sky blue to deep lapis lazuli, reminding us that ice is not just white, but a whole palette of colors. In dry valleys like the McMurdo Valley, reddish-brown rocks emerge against the backdrop of snow-covered plains, creating a unique visual contrast where the beauty of nature manifests in countless forms. These landscapes change over time. In spring, ice begins to melt, revealing the earth beneath, and in summer, when the sun shines around the clock, shadows from mountains and glaciers become longer, creating interesting patterns on the surface. At night, when polar stars sparkle in the cloudless sky, the landscape of Antarctica takes on a mystical aura, and the ice plains and mountains are enveloped in twilight. Scientific research shows that Antarctica is not a static place. It constantly changes depending on the time of year and day. Over the past 10 years, researchers like Dr. Jane Smith have documented significant changes in the character of glaciers, indicating the influence of global warming. These changes affect not only the physical geography of the continent, but also the ecosystems that depend on these landscapes. For example, ice shelves serve as a home for species such as Weddell seals and Adelie penguins, which have adapted to these harsh conditions. Every corner of Antarctica possesses unique characteristics that make it unlike any other place on Earth. The icy cover of Antarctica acts as a giant air conditioner for the entire planet, regulating climatic conditions through the albedo effect. This pristine white surface can reflect up to 90% of sunlight, significantly influencing the temperature not only of the continent itself, but of the entire Earth. Over the past 30 years, scientists have noted a substantial reduction in the area of the ice cover, directly linked to global warming. For instance, a study conducted in 2009 as part of the Antarctic Program project revealed that the area of the ice shield had decreased by 8% compared to the data from the year 2000. This reduction has caused concern among climatologists, as less ice means less reflected light and more absorbed heat. The albedo of Antarctica, reaching a value of 89%, serves as a shield against excessive solar radiation, which, if not reflected, would heat the atmosphere and oceans. An increase in surface temperature leads to the melting of glaciers, which in turn intensifies the warming process, creating a positive feedback loop. A study conducted by the Norwegian Polar Institute in 2015 showed that warming in the coastal areas of Antarctica increases the rate of glacier melting by 30%. This means that with each passing year, the ice cover loses its properties and its ability to reflect solar radiation decreases. Satellite observations collected since 2010 indicate that the temperature in Antarctica is rising faster than in other regions of the world, confirming the relationship between the reduction in ice area and the increase in temperature. Consequently, if the ice cover continues to shrink, this could lead to a global rise in sea level by several meters over the next 100 years, threatening coastal cities worldwide. For example, according to projections, if the sea level rises by 1 meter, it will affect more than 30 million people in megacities like Bangkok and Shanghai. Thus, Antarctica is not just a lifeless icy desert. It plays a vital role in maintaining the balance of the planet's climate and protects us from climate catastrophes that could be caused by its disappearance. There is a direct connection between the state of the ice cover and the climatic changes caused by human activity, underscoring the importance of its protection and preservation. Cryoconite holes are a remarkable manifestation of life in the most extreme conditions on Earth, forming on the surface of glaciers. These small bodies of water appear when dark particles of dust, carried by strong winds, settle on the icy surface, absorbing solar heat and causing the ice beneath to melt. As a result, small but significant ecosystems are created, appearing as tiny dark spots on the vast white expanse of the glacier. These holes can reach depths of up to 1 meter and diameters of up to 2 meters, creating unique microecosystems where life struggles to survive in seemingly inhospitable conditions. In these water bodies, a diverse range of microorganisms, including single-celled algae, bacteria, and microscopic animals such as rotifers and copepods, reside. For example, algae of the genus Chlamydomonas, which can survive in low temperatures and high salinity, form green films on the water surface, transforming these holes into true oases of life. Bacteria like Pseudomonas syringae play a crucial role in the ecosystem, decomposing organic material and creating nutrients for other organisms. These microorganisms form complex food chains where each species depends on another, demonstrating how life can adapt even in the harshest conditions. In such ecosystems, a unique interaction occurs between biological and abiotic factors, highlighting nature's remarkable ability to self-repair and survive. Cryoconite holes serve not only as homes for numerous living organisms, but also as important elements of the climate system, as they can influence the albedo of glaciers by reflecting sunlight and thereby regulating the temperature of the glacier surface. This illustrates that even in conditions where life seems impossible, nature finds ways to maintain diversity and make the world more complex and interesting. Scientists continue to study these unique ecosystems to better understand how they function and how they change in response to climate changes, for example, as a result of global warming. In the inaccessible corners of Antarctica, hidden beneath the ice, lie subglacial rivers and waterfalls that captivate the imagination with their uniqueness. For instance, the blood falls in the dry valleys of McMurdo attract attention with their vivid red color, which contrasts sharply with the pristine white ice and gray rocks. This phenomenon occurs due to the fact that salty water, rich in iron oxide, flows out of a subglacial lake, forming red streams that seem to bleed from the heart of the ice sheet. The water in this waterfall contains ancient microorganisms that have evolved over millions of years in complete isolation from the outside world, creating a unique ecosystem. These organisms are capable of surviving in extreme conditions, making them of interest to scientists studying the potential for life on other planets, such as Mars. Research indicates that similar microorganisms could serve as a model for searching for life in the subglacial oceans of planets' moons, such as Europa. The water flowing from the blood falls has a temperature of around -2 degrees Celsius, making it less dense and allowing it to move beneath the ice cover. This process not only creates a visually stunning spectacle, but also influences the dynamics of glaciers and local ecosystems, providing necessary conditions for the existence of specialized organisms. Studies conducted since the early 2000s show that such subglacial rivers can be important indicators of climate change, as they respond to temperature fluctuations and sea level changes. The blood falls, discovered in 2013, has become the subject of numerous scientific investigations, and its study offers a unique opportunity to understand how life can adapt to extreme conditions. Observations of this phenomenon demonstrate that even in the harshest conditions on Earth, life finds ways to manifest itself, opening new horizons for humanity in the search for extraterrestrial life. Antarctic shelf glaciers are colossal floating ice platforms that extend from the continent's shore into the ocean for hundreds of kilometers. These natural giants can reach the size of France and have a thickness of several hundred meters, forming truly magnificent structures that are impossible to miss. Their dazzling white surfaces gleam in the sun, contrasting with the deep blue waters of the ocean, while the sheer cliffs, as high as a multi-story building, evoke both awe and dread. Within these ice masses lie thousands of years of history, with air bubbles trapped in their structure, preserving the atmosphere of ancient epochs, making them true archives of climatic changes. When icebergs break off from the shelf glaciers, a thunderous roar echoes through the area, sometimes accompanied by a soft creaking, like the whisper of an old tree. These sounds indicate that the glaciers are constantly in motion, and their changes can threaten the stability of the entire ecosystem. Shelf glaciers play a critically important role in stabilizing continental glaciers, acting as a kind of plug that prevents them from moving towards the ocean. When shelf glaciers begin to melt, this accelerates the rate of glacier retreat, leading to a rise in sea level. For instance, the Larsen Shelf Glacier, which in 2012 lost a vast area of ice the size of the United Kingdom, serves as a stark example of how climate change can affect such structures. As a result of this event, sea levels worldwide could rise by several millimeters, which may seem insignificant but has far-reaching consequences on a global scale. Statistics show that over the past 30 years, the area of shelf glaciers has decreased by more than 30%, and this trend is continuing to grow. Scientific research conducted by the Institute of Oceanography in Seattle indicates that such a loss of ice could lead to catastrophic changes in coastal ecosystems and contribute to global climate changes. Antarctica is not just an icy continent, it is a true treasure trove of cosmic mysteries. Meteorites found on its surface are dark stones that contrast with the whiteness of the ice, like black pearls on white velvet. These stones vary in size and shape, from small fragments to large boulders, each with its own story. For instance, some meteorites, such as the Allahabad meteorite, have been identified as Martian, making them witnesses to the ancient history of our planet and its neighboring red planet. Others, like the Moon meteorite, brought us pieces of the Moon that were ejected into space during powerful volcanic eruptions. Glaciers moving across the continent create unique meteorite traps, concentrating these unique objects and making their discovery easier. Research conducted in the 2000s showed that approximately 30% of the meteorites found on Earth were discovered in Antarctica. This is not only due to the contrast between the dark meteorites and the white ice, but also to the exceptional conditions for preservation. The dry and cold climate prevents erosion and contamination, allowing the meteorites to remain in their original state. Scientific expeditions, such as the ANSMET project, have been actively searching and studying these cosmic bodies since the 1980s. Over the years, the team has discovered more than 2,000 meteorites, providing scientists with a unique opportunity to study their composition and age. For example, the Taylor meteorite, found in 2001, is one of the oldest meteorites, dating back more than 4.5 billion years, and is a significant witness to the early processes of the formation of our solar system. With such findings, we can better understand how the processes of planetary evolution occurred and what conditions existed in the early stages of Earth's existence. Meteorites from Antarctica are not just pieces of space, they are keys to unraveling many mysteries that remain unsolved. Scientists continue their work on their analysis, using modern methods such as mass spectrometry and electron microscopy to obtain information about the chemical composition and mineralogy of these cosmic bodies. At the bottom of the icy expanses of Antarctica, hidden beneath the ice, are not only meteorites but also fossilized remains of ancient forests that once covered this continent. Discoveries made by scientists include well-preserved tree trunks with distinct annual rings, allowing researchers to determine the age of the trees and the climatic conditions in which they grew. These fossils, dating back over 100 million years, reveal that during the Cretaceous period, Antarctica was not an icy wasteland, but a thriving ecosystem with abundant vegetation. Specifically, researchers have identified remnants of southern beech trees that could reach heights of up to 30 meters, as well as various types of ferns and conifers that form dense forests. The found leaf impressions have clear veins and sizes ranging from several centimeters to over 10, indicating the diversity of flora at that time. For example, impressions of conifers from the family Araucariaceae were discovered in the area of the Ross Sea, indicating the presence of a warm and humid climate. These findings help scientists reconstruct the climatic conditions that prevailed on the continent millions of years ago, allowing them to understand how the ecosystem of Antarctica has changed over time. Analysis of pollen and spores found in the layers of fossils shows that the flora was diverse and included not only conifers, but also deciduous plants, providing insights into how the ecosystem adapted to changes in climate. It is important to note that such research can shed light on how climate change affects contemporary ecosystems, as the history left by these fossils can help us better understand how ecosystems respond to global climate changes. For instance, a study conducted in 1985 by a group of scientists led by Dr. John Mayers showed that the average temperature during the time these forests existed was 10 degrees higher than it is now. Such data could be critically important for predicting future climate changes and understanding the biosphere of our planet. Comparing the current icy landscape with images of ancient forests creates a stark contrast, highlighting how dramatically this continent has changed over millions of years. This transformation not only led to the disappearance of forests, but also to the formation of unique ecosystems that we observe today. As a result, the discovery of fossilized forests in Antarctica not only astonishes, but also provides valuable data for studying the biological history of Earth and its climatic changes. Beneath the thick ice of Antarctica lies a remarkable landscape, not a flat surface, but a complex network of subglacial mountains and deep valleys. The Transantarctic Mountains, stretching across the continent for 3,500 kilometers, form a true artery dividing Antarctica into eastern and western parts. These mountain ranges reach heights of more than 4,000 meters above sea level, creating powerful barriers to the movement of glaciers. Along these mountains stretch deep canyons, some of which descend below sea level, creating unique conditions for the formation of glacial flows. For example, the Ferrar Glacier, which descends into one of these lowlands, demonstrates how the landscape can direct the movement of ice, causing the formation of massive crevasses and flows that rush towards the ocean. In this hidden world beneath the ice, glacial flows seem to dance, following the natural contours of the landscape, creating a complex network of ice that varies from single-layered to multi-layered structures. These ice formations are not static. They constantly change under the influence of internal and external factors, including temperature, pressure, and even tectonic processes. For instance, recent research conducted by an international team of scientists in 2020 showed that subglacial rivers flowing through these canyons can significantly accelerate the movement of glaciers, which in turn affects sea level. If the ice were to ever melt, Antarctica would look completely different, resembling an archipelago of islands separated by straits rather than the single landmass we are accustomed to seeing on maps. Scientific research indicates that if all the ice were to melt, sea levels could rise by more than 16 meters, leading to the flooding of major coastal cities around the world. Such a scenario would represent not only a geographical, but also an ecological catastrophe, affecting millions of people. The complex landscape of Antarctica, in turn, creates unique ecosystems that may never be fully explored. For example, subglacial canyons like the Drake Canyon are home to numerous marine species that have adapted to extreme conditions. These species not only survive but thrive in conditions that seem impossible for life. Research conducted under the Polar Research Project shows that many of these organisms possess unique biochemical properties that could be used in medicine and biotechnology. Thus, the subglacial world of Antarctica is not only a geographical enigma, but also a potential source of new scientific discoveries. Subglacial canyons of Antarctica are remarkable geological formations that in some places are even deeper than the famous Grand Canyon. For instance, the canyon under the Denman ice shelf, discovered in 2018, is considered the deepest point on Earth, plunging to 3,500 meters below sea level. This canyon was formed millions of years ago when ancient rivers flowed across the continent, carving deep channels in the soft ground. With the change in climate and the onset of glaciation, these rivers became covered by ice sheets, and the resulting massive ice masses began to deepen the existing canyons, giving them their modern appearance. Scientific research shows that these subglacial canyons are not only geological wonders, but also play a crucial role in understanding the hydrology of the region. Scientists such as Dr. Jonathan Bock and his team from the University of London study how water circulates under the ice sheet, which in turn can affect the stability of the entire ice cover. These studies are important because climate change can lead to rapid melting of glaciers and, consequently, to a rise in sea levels. Water under pressure creates complex water systems that can influence the movement of glaciers. Each new discovery in these canyons provides scientists with valuable information about how climate changes can affect ice masses and, consequently, the entire planetary climate. For example, in 2020, a group of Swedish researchers discovered an extensive network of underground rivers under the Thwaites ice shelf, which could accelerate the melting of ice. These data help create models that predict how quickly the ice sheet will respond to temperature changes. Subglacial canyons hide not only geological mysteries, but also keys to understanding the future of our planet. At depths inaccessible to human eyes, there is a complex ecosystem full of life and adaptation that can tell us about the past and future of Earth. In Antarctica, unusual atmospheric phenomena can captivate even the most seasoned researchers. One of the most striking effects is the halo, a rainbow-like ring that forms around the sun or moon when light is refracted by ice crystals floating in the atmosphere. These hexagonal crystals act as prisms, creating remarkable optical effects. On the bright Antarctic sun, a halo can appear as a wide rainbow ring surrounded by a white border, sometimes with more complex structures resembling an aureole. Researchers like Ernest Shackleton in the early 20th century noted in their diaries that halos create an illusion of the sky being painted in vivid colors, elevating the atmosphere to almost a mystical level. Parhelia, also known as false suns, are another fascinating phenomenon. They occur when sunlight passes through ice crystals in the atmosphere, creating two bright spots on either side of the sun's disk. These bright spots can be almost deceptive, making the observer think the sun has split in two. This effect is particularly striking in the evening hours when the sun is low on the horizon and the sky is painted in warm hues. At such times, Parhelia can appear as two small stars shining next to the sun, lending a magical quality to the landscape. Light pillars are yet another breathtaking phenomenon. They are vertical bands of light rising from the horizon to the sky, sometimes reaching heights of several tens of degrees. These pillars form when light is reflected off ice crystals in the air and can be seen in conditions of low cloud cover when sunlight penetrates through the clouds. On clear nights, when the moon is bright, light pillars can be equally spectacular, giving the illusion of light rising into the celestial vault. These atmospheric phenomena are not only beautiful but also change depending on the time of day and the state of the atmosphere. For example, in the early morning, when the air is still cold, halos appear sharper and brighter, while at midday they can seem more diffuse. The state of the ice and clouds also influences the intensity and color ranges of these optical effects. Researchers like Robert Falcon Scott described in their chronicles how these natural light shows sometimes evoked a sense of awe and otherworldliness, possibly due to the isolation and harsh conditions they were in. In the diaries of polar explorers, these phenomena are often described as omens from above. Halos and parhelia appearing against the vast white expanse were seen as portents or symbols of good fortune. The incredible color plays created by the ice crystals gave this harsh environment a magical quality, making people feel connected to something greater than themselves. These legends of light shows occurring at the edge of the world became part of the mythology of Antarctic expeditions, adding another layer of mystery to the already enigmatic continent. Temperature and humidity affect the appearance of these effects. In dry weather, when the air is clean, light phenomena become the most vivid and distinct. Humidity can blur the edges, shifting light into less pronounced shades, creating a completely different atmosphere. As a result, each visit to this frozen desert can be a unique experience where nature demonstrates its ability to transform light into art. Ultimately, these atmospheric phenomena not only enhance the Antarctic landscape, but also serve as a reminder of how wondrous and complex our world is, even in its most severe corners. Imagine standing on the frozen plateau of Antarctica's ice sheet, where powerful katabatic winds suddenly burst forth, rushing towards the coast under the influence of gravity. These winds, capable of reaching speeds up to 300 kilometers per hour, are the strongest on Earth. Their roar resembles a low growl that gradually intensifies into a piercing whistle, evoking a sense of unease and trepidation in people. When a katabatic wind unleashes its fury, it lifts snow particles, creating a white fog that obscures the horizon and makes the world around seem completely unfamiliar. This sudden whiteness does not merely restrict visibility, it creates an illusion of disorientation, where even the most familiar landmarks become indistinguishable. The force of these winds can knock down even the sturdiest people, and light structures like tents can be overturned or torn apart. The landscape of Antarctica is constantly shaped by these winds. They form intricate snow and ice formations, carve out entire valleys down to the bedrock, leaving behind only bare earth. These winds not only cause physical changes, but also have ecological effects, influencing animal migration and the distribution of vegetation in this harsh climate. For instance, in areas where the winds are strongest, plant growth can be significantly restricted, while in sheltered areas a more diverse flora can be observed. The wind that tears through space has become a key factor in shaping the unique Antarctic landscape and ecology, and researchers continue to study its impact. Katabatic winds are not just a natural phenomenon, they represent a powerful force capable of drastically altering the world around. They are an integral part of the Antarctic ecosystem, playing a crucial role in climate processes and the formation of glaciers. Polar night and polar day in Antarctica create unique conditions that significantly differ from the familiar rhythm of life on other continents. During the Antarctic winter, which lasts from March to September, the sun does not rise above the horizon for several months, plunging the continent into complete darkness. This uninterrupted darkness has its own characteristics. The sky becomes a deep black, studded with bright stars, and in the winter months, amazing phenomena such as polar lights occur, which captivate with their light and colors, dancing over the cold expanses. These bright flashes, sometimes tinged with green, purple, and even red, evoke awe and reverence in those who witness them. On the other hand, during the Antarctic summer, from September to March, the sun does not set below the horizon, creating the effect of an endless day. The sky takes on a pale blue hue, and the sun describes circles, as if dancing over the horizon, creating light reflections that illuminate the ice fields and mountains. These extreme lighting conditions have a significant impact on the biological rhythms of all living beings, including people working at Antarctic stations. Studies show that the prolonged absence of sunlight during the winter months can cause sleep disorders and mood changes in people. Station staff must adapt to these conditions, using special lamps to simulate sunlight and maintain a normal sleep-wake cycle. It is important to note that polar nights and days affect not only people but also the flora and fauna of the continent. Some animal species, such as penguins, use these extreme light conditions for their migration and reproduction. For example, emperor penguins, which lay eggs during the Antarctic winter, have adapted to the long darkness and cold, using their natural instincts to survive in conditions where temperatures can drop to -40 degrees Celsius. Meanwhile, other species, such as seals, use the polar day to actively search for food on the ice surface. These aspects of life in polar night and day conditions underscore the uniqueness and harshness of Antarctic nature. Each year in Antarctica, numerous studies are conducted to investigate these phenomena and their impact on the ecosystem, highlighting the importance of this continent for understanding global climate changes and the adaptation of living organisms to extreme conditions. In Antarctica, there live remarkable microscopic creatures known as tardigrades, which exhibit an extraordinary ability to survive in the most extreme conditions. These tiny organisms, measuring only about 1 millimeter in length, resemble small 8-legged creatures with a bear-like gait. Tardigrades can withstand temperatures close to absolute zero, down to -88 degrees Celsius, and yet retain their viability. They can tolerate high doses of radiation, far exceeding what would kill a human, and can survive in conditions of extreme dehydration, where the moisture level in the environment approaches zero. This is all thanks to their unique ability to enter a state of cryptobiosis, a state in which all life processes virtually cease. In this state, tardigrades can remain for decades, and some specimens found in Antarctic ice have been activated after more than 30 years of freezing. Under a microscope, tardigrades appear as miniature beings with 8 legs, with which they move across the surface like bears crawling on ice. Research on these organisms has been conducted by scientists since the 1990s, when a group of biologists led by Professor David Dolan from the University of California began studying their remarkable abilities. During experiments, scientists discovered that tardigrades can survive conditions that would be considered lethal for most known forms of life. They can adapt to extreme changes in pressure, high levels of radiation, and even deep space vacuum. This discovery raises important questions about the limits of life's survival on Earth and beyond. Studying tardigrades may provide a key to finding life on other planets with harsh conditions, such as Mars or Jupiter's moons, where temperature, radiation, and pressure can be extremely unfavorable for traditional forms of life. These organisms serve as a model for astrobiologists seeking to understand what forms of life might exist in conditions previously considered inhospitable. Tardigrades are not the only extremophiles living in Antarctica. In the icy waters, there are also archaea and bacteria that can survive high levels of salinity and low temperatures. Scientists like Dr. Christopher Reynolds from the University of Edinburgh study how these organisms adapt to their environment, revealing new horizons in understanding life on Earth and beyond. Extremophiles like tardigrades highlight how life can manifest in the most unexpected forms and conditions, opening new perspectives for biology and astronomy. Antarctica is not just an icy continent. It is a unique example of international cooperation where political differences are set aside in favor of science and peace. The Antarctic Treaty, signed in 1959, laid the foundation for the continent's status as a territory belonging to no single country. In accordance with this agreement, Antarctica is to be used exclusively for peaceful purposes, which means a ban on military activities, nuclear tests, and the extraction of minerals. Currently, more than 30 countries are involved in research activities on this continent, establishing research stations that operate in extreme cold and isolation. For instance, Russia's Mirny Station, founded in 1956, and the US McMurdo Station, active since 1955, are located just a few hundred kilometers apart, symbolizing cooperation between nations. Joint expeditions are conducted regularly, and scientific research data is exchanged between countries without any restrictions, fostering an atmosphere of trust and mutual understanding. Scientists from around the world are working on studying climate changes, ecosystems, and even searching for new microorganisms that could be beneficial to science. In 1981, the Protocol on Environmental Protection was adopted, strengthening the protection of Antarctica and emphasizing the importance of preserving its unique ecosystem. This document expands the scope of the treaty, prohibiting any actions that could harm the environment, making Antarctica a model for environmental conservation. Since the continent remains one of the last wilderness areas on Earth, its status as a zone of peace and science continues to inspire scientists and diplomats to achieve new feats. In fact, within the framework of the Antarctic Treaty, continuous monitoring of the environment's condition is carried out, and scientific symposia are held where research results and future plans are discussed. Scientific research in Antarctica covers a wide range of topics, from studying the ice cover to analyzing ocean changes, confirming its importance for global understanding of climate changes.